Okay, so if we're gonna, section is 2.3 and 2.4. Okay, so average rate of change. When you see the term average rate of change, you should always think slope. If you think of slope, you'll be good in a good place. When you think about finding the average rate of change, you're going to be able to find it given 2 points. Those points might come from a table. Those points might come from a graph, but it's really just the point A, f of A, and B, f of B. So the slope between these 2 points, or the average rate of change, is just going to be doing the slope. So f of B minus f of A divided by B minus A. So just using the slope formula. If we take a problem like this, which came from Delta Math, and it asks us to find the average rate of change of G on this interval. Now, Delta Math is doing this, is going to ask you to do it simplified, so we'll talk about what you need to do for the AP exam and what you need to do for this. So if you look at this thing, we're looking at G of X, so that's this line down here. So if we go from 0, 4, that's a point, to 9, 1, that's another point, then the average rate of change of G on this interval, 0 to 9, would equal 1 minus 4 divided by 9 minus 0, or negative 3 over 9, or negative 1/3. So for the AP exam, this is all you want. For AP, this is what we want. This is called a difference quotient. For Delta Math, this is what we want. So just 2 different things. But for the AP exam, we just want to know the difference quotient, and you don't have to simplify it. On today's assignment, you're going to have to do something with the tangent line. Or actually, I don't think you have to do it with the tangent line today, but just know that this is something that we're going to use a lot. So if we have a point, and the point might be generically A comma f of A, so just 2 numbers, just a point, and we have the slope. That's going to come from the derivative in calculus, and generically it's f prime of A, so those are just numbers. Then the tangent line is going to be f prime of A times x minus A plus f of A. Okay, let's talk about when a graph is not differentiable. A graph is not going to be differentiable, so you can't find a slope. Think of it that way. Can't find a slope, or it's undefined. Slope. When you think about where that would exist, it certainly would exist at a jump. It would exist at a hole, and it would exist at a vertical asymptote. All of those are places where we don't have continuous continuity. So we don't have continuity, and the graph is also not going to be differentiable. The other place that we're going to look for is we're going to look for a sharp change in the graph, and we're going to look for when the graph goes vertical. It's another place. All of those, we do have continuity. So there are places where you can be continuous but not differentiable. You can't ever be not continuous and be differentiable. So if a function is not continuous, it's not going to be differentiable at that place. So take a look at this, and if you look at this problem, it says, use this graph, figure out where this function is continuous but not differentiable. Go back up to this list. If it's continuous but not differentiable, we're looking for sharp changes or when the graph goes vertical. We'll take a look at this, and right here, there's a sharp change when x is equal to -4. Right here, the graph is vertical when x is equal to 0. Right here, we have a vertical asymptote when x is equal to 5. So the answer to this question is x is equal to -4 and 0. Those are the places where this function is continuous but not differentiable. Here's a problem that asks you to determine if the function is differentiable, continuous, neither at this value. So one thing we could do is, if we needed to, we could find a derivative. And it would be pretty easy to find this derivative. We could just use our derivative rules. This would be 2x minus 6. This would be -18. This is x is less than -8. This is x is greater than or equal to -8. So if we wanted to figure out if it's continuous, let's check that first, because if it's not continuous, it's not going to be differentiable. So if continuous, then the limit as x goes towards -8 from the left side, which is x squared minus 6x plus 20, would have to be equal to the limit as x goes towards -8 from the right side, which is -18x minus 16. Now we can do both of those, because just with direct substitution, and kind of figure out if these limits exist and what they are. If they're equal, then we have continuity. But if they're not equal, we don't have continuity, and therefore we would never have differentiability. So if we do direct substitution on this, we got -8 squared minus 6 times -8 plus 20. So that's 64 minus 48 plus 48 plus 20, which is 132. On the other side, we have -18 times -8 minus 16, which is 144 minus 16, which is 128. So these are not equal. So this is not continuous, which means it is also not differentiable in this case. Okay, so that's that problem. Here's the last problem. Then you can do your Delta Math assignment. Find the values of a and b which would make this function differentiable. So let's look at find the derivative first. So f prime of x would equal 2a for x less than or equal to 2, 2bx minus 4 for x greater than 2. So if this function is differentiable, if this function is differentiable, then 2a would have to equal the limit as x goes towards 2 from the right-hand side, 2bx minus 4. Now we'd have to use the limit notation on that, because notice from the right-hand side, x doesn't equal 2, x is just bigger than 2. So we'll just use the limit notation. It doesn't really change our computations after that, after writing that limit notation, because this is just simply 2a is equal to 4bx minus 4. So here's one equation that we need. Okay, so now we also got to do the same kind of thing with continuity. So if continuous, notice if it's differentiable, it might be continuous also. So if it's continuous, we need the limit as x goes towards 2 from the right-hand side, from the left-hand side, 2ax plus 10 to equal the limit as x goes towards 2 from the left-hand, or from the right-hand side now, of bx squared minus 4x plus 9. And now I'm going to do some simplification on this. I get to plug in 2, so I get 4a plus 10 needs to equal 4b minus 8 plus 9, or 4a plus 10 has to equal 4b plus 1. So we need this. So we have these two equations. Got two variables, two equations, we can just solve them. So if we think about what we have here, I'm going to rewrite these equations down and go about solving them to figure out what a and b have to be. So I got the equation 2a is equal to, I feel like this x should not be there, so let me get rid of that x, because that x should not be there. Because if I put 2 in, I got 4. So 2a is equal to 4b minus 4. And I also have 4a plus 10 has to equal 4b plus 1. So that's the two equations that I'm going to solve. Now I'm going to do something a little bit tricky and unique with this equation right here. What I'm going to do is I'm going to write this as 2 times 2a plus 10, because that's just 4a, equals 4b plus 1. The key to doing that is notice that I can take this and plug it right in there, because that's what 2a equals. So I have 2 times 4b minus 4 plus 10 is equal to 4b plus 1. And now I'm just going to go through and do some algebra. 8b minus 8 plus 10 is equal to 4b plus 1. So 8b plus 2 is equal to 4b plus 1. So 4b is equal to negative 1. So b is equal to negative 1/4. If b is equal to negative 1/4, we can use this equation right here, along with b equaling negative 1/4, and solve for a. So 2a is equal to 4 times negative 1/4 minus 4. 2a is equal to negative 1 minus 4, which means a is equal to negative 5/2. There's our two values. Hopefully that makes sense. Good luck.